we are going to go over stuff you need to know before starting this assignment, building a model to predict the weight of an object. Now, some of this is review, but anyway, you got to write it down. So I'm going to go through it. We're going to fill out the notes together. All right, why are we doing this assignment? Well, purpose of the assignment, people all over the world every day confuse mass and weight. They think it's the same thing. They're not. Your job at the end of this assignment is to tell me, to know that they're different. Okay. Also, we want to develop a model that can predict the weight of an object at any place in the universe. All right, what you should know before we start this assignment. Again, here's the problem. Most people believe the terms mass and weight are different words for the same thing. That is not true. Sad but true. By the end of the assignment, you will not be one of those people. What is mass? The mass of an object is the measure of the amount of matter in an object, whatever that object is. Could be the sun, could be an electron. Okay, that's what mass is. Okay, well then the question is, what is matter? Think protons, electrons, and neutrons. How do you spell neutrons? I'm going to guess. Close enough. I think that's right. All right, and we don't even really worry that much about electrons. When we get to the unit on electricity and charge, we'll see that the mass of an electron is super, super tiny. It's not zero, but even compared to a proton, it's super, super tiny. Now, if these subatomic particles were larger, we would quantify the mass of an object by counting them. Counting the number of protons, neutrons, and maybe the electrons, or we could potentially ignore those because they are so small. Okay, that's what we would do. Any other object with the same number of these subatomic particles would have exactly the same mass and in essence the same inertia. Okay, now we can't count protons, electrons, and neutrons. They're way too numerous. So now we're going to introduce this idea of a kilogram. Practically speaking, subatomic particles are way too numerous in number and way too small to count. So humans have devised another way of quantifying mass more suited to our senses, our ability to observe. Okay, I can see that chunk of metal there. I cannot see protons, neutrons, electrons. Okay, we quantify mass in kilograms. When we do, we are comparing the amount of matter in an object to the amount of matter in the prototype kilogram in Paris, France. And we have copies in our country. And I know you're saying, hey, McIntyre, this prototype kilogram, that definition has been is now obsolete. We have a different way. I know, but I don't want to. This you can see, you can understand. The other one is more abstract. We can always talk about it later. Okay, what is a prototype kilogram? It's a platinum iridium cylinder located in a vault in Paris, France. In the International System of Units, the cylinder, by definition, has a mass of 1 kilogram. You say, how many sig figs? There are none, because it's defined to be a kilogram. All right, moving on. What is weight? Well, let me start with this. Weight and mass are not the same thing. Weight is the force of gravity. It's gravity. And what is gravity? It's, if you're on Earth, it's the pull. It's literally the pull of the Earth on you. So we have 3 different ways of describing the same force. Weight, gravity, and pull of the Earth are 3 different ways to describe the same force that's acting on you right now. Okay, if you're on the moon, of course, it wouldn't be the pull of the Earth that would dominate. It would be the pull of the moon. Weight and gravity, I guess I've already emphasized that, Now, there are two words that are the same thing. Weight and gravity are exactly the same thing, but not weight and mass. Okay, in the SI system of units, weight, like all forces, is measured in newtons. Another common unit for measuring force in everyday life is the pound. Okay, 1 pound is approximately 4 newtons. If you want to be more specific, it's 4.45 newtons. Are weight and mass related? Even though mass and weight are not the same thing, you probably have a sense they are related. For example, would you be shocked to find out that objects with more mass, like elephants, weigh more than objects with less mass, like mice? Of course not. You've been around long enough to know that. So there is a relationship between mass and weight. They're not the same, but they're related. So this is our goal. Our goal is to develop a model for predicting the weight. What am I going to write here? Predicting the weight of any object in the universe. Okay, there you go. That's the end of the notes. Have fun.